All right, for this example, we're told that Krysti invests $300 in an account with an interest rate of 6%, making no other deposits or withdrawals. And we're asked how much money is going to be in that account after 20 years if the interest is compounded semi-annually, monthly, daily, or continuously. All right, so our compound interest formula is this. It's the amount in the account at the end is going to be equal to the principal amount, the amount we put in the beginning, times 1 plus the interest rate, the annual interest rate as a decimal, divided by the number of times per year the interest is compounded, to the n times t, where t is the time in years. So here, we want to know how long or how much money this is going to be in that account if the interest is compounded semi-annually, meaning twice a year, so that our n is going to be 2, or monthly, so our n would be 12. We're going to compound it 12 times per year, or daily, so we're going to compound it 365 days, 365 times in a year. All right, so let's figure out those three first. So the amount in this account after 20 years is going to be equal to, if we start with n equals 2, our principal is $300, and we're multiplying that times 1 plus our interest rate as a decimal. It's 6%. As a decimal, that's 0.06. Divided by n, which is 2. And we're taking that to the 2 times t, which is 20 power. And we can plug all of this into our calculator. If we do that, we're going to find that this is approximately equal to $978.61. So we can put that up in here in this chart here. This is going to be $978.61. All right, and then we're going to do that same thing with an n of 12. So the only thing we're changing here is our n. We still have a principal of $300. Our interest rate is still 6%. Our time is still 20 years. We're just compounding this more often. So we're putting a 12 down here and a 12 up here in the exponent as well. And if we plug that into our calculator, we're going to find that this is approximately equal to $993.06. So let's put that up here under n equals 12. So $993.06. All right, the same thing now for an n equal to 365. So notice what we're doing when we do this. We're dividing this interest rate by n, because we're not earning the full 6% every time we compound this. We're earning just that fraction of the interest rate that corresponding to the fraction of the year that we've gone through. But then we're taking that to a higher power. So if we plug this into our calculator, this is going to be very similar to the monthly amount. This turns out to be $995.94. So we can plug that into 365. That is our amount for compounded daily. All right, now we need to go to compounded continuously. So for this one, we have a different formula. This is our compound interest formula. The formula for continuously compounded interest is A equals P, still the principal, times E to the rate times time. So notice we don't have an n in here anymore, because now our n is infinite. We're compounding this continuously. And E is not a variable. E is a constant. It's equal to approximately 2.718. All right, so if we plug this in, now our P is still 300. Our E is a constant. our rate is 0.06, and the time is going to be 20 years. And we can plug this into our calculator, and this is going to give us an approximate value of $996.04. So notice we haven't gained a lot by compounding it continuously versus daily. It's just an extra 10 cents. All right, so that's the full answer with semi-annually, monthly, daily, and compounded continuously.